Right now, a rare visitor is reaching its absolute peak in our skies. Within days, it will fade completely out of view. Most people will miss this event entirely. While the comet is currently bright enough to observe, the time remaining to find it is measured in hours, not weeks. This is Comet C 2025 R3, also known as PanSTARRS. It's making a massive, sprawling loop through our solar system, returning to our skies for the first time in nearly 170,000 years. This map charts its origin. It began in the distant Oort cloud, a vast, dark shell of ice beyond Pluto. After thousands of years in darkness, a slight gravitational nudge altered its path, sending the ice ball plummeting towards the sun. What we are experiencing in this fleeting week is the absolute climax of an isolated journey spanning hundreds of millennia. As the comet crosses into the inner solar system, intense solar radiation rapidly boils its ancient frozen surface. Deep fissures crack open, aggressively venting streams of trapped gas and dust out into the vacuum of space. This escaping debris creates what astronomers call a coma, a glowing cloud surrounding the comet's core. Sometimes solar wind pushes that material backward, forming a faint trailing tail. From Earth, PanSTARRS appears as a soft, hazy glow. It's quiet, subtle, and lacks the sharp, glowing streak often associated with comets in films. This map tracks the comet's path toward perihelion, its absolute closest distance to the Sun. Hitting that point triggers maximum heating, maximum outgassing, and peak visual brightness. But this creates a viewing paradox. As it nears the Sun, solar glare drowns out the comet completely. The cosmic mechanics working to illuminate this frozen relic are the exact same mechanics working to erase it from our view forever. If you live in the Northern Hemisphere, your time has practically run out. The comet is currently rising just before dawn, sitting dangerously low on the horizon. To catch it, you have to aim for a very specific, narrow window between 3 and 4:30 a.m. You will need an unobstructed horizon, completely dark skies, and a decent pair of binoculars. If you sleep through those morning hours, the comet gets swallowed by the dawn. There is no makeup day. However, observers in the Southern Hemisphere are experiencing the opposite timeline. Down there, the story is only just getting started. This chart illustrates the visibility split. As the northern viewing window drops to zero, the comet emerges from solar glare for the south. By late April into May, it climbs higher into the evening sky, becoming much easier to spot after sunset. Regardless of where you live, optics make the difference. Comets are notoriously unpredictable, and relying solely on the naked eye will likely leave you disappointed. Since we cannot calculate exactly how bright the ice will glow, locking into these specific timing windows and using the right equipment is your only reliable way to capture the event. Many celestial events drift across the sky for a full season, but PanSTARRS is far more fleeting. The window to witness it is happening exactly right now. Within a matter of days, PanSTARRS will push too close to the Sun. The sheer volume of solar light will scatter through our atmosphere, effectively turning off the comet's visibility entirely. When that happens, it is entirely over. You won't be able to wait a few hours for the sky to darken, and trying again the next night won't work. This timeline reveals the sheer disparity of scale. A cosmic journey lasting 170,000 years is culminating in a microscopic, days-long sliver of time where human eyes can actually track it. If you have clear skies tonight or early tomorrow morning, step outside. Point your binoculars toward the horizon and give yourself a few quiet minutes to look. Because if you manage to find that faint, glowing patch in the dark, you will join a tiny fraction of humanity to witness a visitor that won't return to our skies for hundreds of generations.